Hello ladies and gentlemen, welcome back. This is Mr. Dang. It's good to have you here with me today to go over Electron Configurations. I just had that music in the background just to make me feel at home a little bit here. So let's get started. At this point, you should have this Electron Configuration, the boarding house model completed. This is the introduction. You should have worked on it on your own. You should be able to follow the instructions and answer these questions. And if you do have any questions, ask your teacher for some help. Okay, there's no video over this first one, but before we move on, I'd like to go over a few things that was on this. Three things. The three principle. The first one is the off-bow principle. Okay, it tells about electrons filling in from the ground state. Let me get a piece of paper real quick. So off-bow principle. It's basically, it fills in from lowest to highest energy level. So from lowest to highest energy level. And I'll explain what this means in a little bit. Okay, off-bow, lowest to highest energy. The second one is on the next page. Pauli exclusion principle. Pauli principle. Tell you that if you have two electrons or two people in the same room, or sometimes we do the Hogg-Hilton one, they have to have opposite spins. Okay, so opposite spins. It's fine. Okay, opposite spins is the Pauli exclusion principle if they are in the same orbital. And so some words here, orbital is where the electrons are, and if they're in the same one, it's just like your bunk bed. Every bunk, there's it can fit. Let me go back if I'm saying the right thing here. Yes, every room can hold two people, and so basically orbital is every room here can hold two electrons. And then the last one, Hund's rule. Hund's rule. Hund's rule is it's kind of like this. If you have three rooms on the same level, you have to put one person. Basically, you have to put one person in each room before you can pair them up. Okay, so one in each orbital before pairing. On the same level. Okay, one on each level orbital before pairing on the same level. Okay, so keep those in mind, and you should have gotten that out of this packet, as well as some introductory, some letters, some little letters, some numbers, what they mean, and I will go over that right now. You should have this paper in front of you. Yours will not be colored like mine. I got a fancier printer, and so yours is black and white. Make sure, but the content is exactly the same. You should also have a nice handy dandy periodic table available. It should be glued into your notebook already. Okay, it should be glued to your notebook. So you have that. It's nice to do that. Okay, there are four orbitals, ladies and gentlemen. Back in Bohr's model, they were rings, right? And so later on, and the electrons were on these rings. And later on, the quantum mechanics model, which is by Heisenberg and Schrodinger, they did all the mathematics and they figured out that there are actual electron clouds, and these clouds are what we call these orbitals. Okay, and they're on each energy level. You can have different sublevels. So you'll see things like 1s something, 2s, 2p, whatever those are, or those little things, these letters. Okay, this first number is the energy level. Kind of corresponds with the row that it's on. Okay, the S, like 1s, that means it's on row 1, 2s on row 2, 3s on row 3, 4s on row 4, 5s on row 5, 6s is on row 6, 7s is on row 7, and it works the same for P. P is 2p's on row 2, 3p's on row 3, 4p's on row 4, 5p's on row 5. Okay, but the D though, it's one lower than that. So if it's 4s on the same row, it would be 3d. And the F is going to be one lower than that later on. I'll explain that later. But the S and the P will determine the level, the energy level that it's on. And then we have different sublevels. The letters tell you sublevels. There's sublevel S, there's sublevel P, there's sublevel D, there's sublevel F. I don't know if those letters stand for anything, but there's some correlation here with the S. The shape is kind of like a sphere. So these electrons could be anywhere within this sphere here. So let me move this over that way. There you go. So S can be in a sphere. P, there's 3 P sublevels. So there's 3 P's. And then D, there are 5. So S is 1, P is 3, D is 5, F is 7. And each orbital is kind of like one of the room in the last exercise. Each orbit can hold 2 electrons. Each orbit can hold 2 electrons. So therefore, that's how we get S level can hold 2. P, 2 times 3 orbital times 2 gives you 6. And then 10 for D, F for 14. Okay, you do have to memorize these numbers. S can hold 2, P can hold 6, D can hold 10, F can hold 14 because they have 1 orbital for S, 3 orbitals for P, 5 orbitals for D, and 7 orbitals for F. Okay, so keep those in mind. And you can actually go down here and finish this box right here. If it's a 2S, you just look at the letter. Okay, the first number tells you the energy level only. The sublevel, the S, will tell you how many it can hold. So here's S, it can hold how many? Back to the list. S can hold a maximum of 2. Okay. And then F can hold how many? 4F. 4F can hold 14. Good job. Good job. Give yourself a pat on the back. And then 3D. D level can hold 10. Yep, you are right. And then 5P. P can hold what? 6. And D can hold how many? Back to D here. 10. Okay. S can hold 2. P can hold 6. D can hold 10. F can hold 14 because they have different number of sublevels. This is a number of orbitals, I'm sorry. And so to follow those rules, remember those 3 rules I just mentioned earlier? You got off-bow principle, lowest energy to highest energy. And to follow that rule, we have to follow this. Well, there's a really cool way to follow that, and it's pretty simple. It's called the diagonal rule. Here it is, the diagonal rule. This is not going to be provided to you on any test or quiz. You have to be able to draw it out on your own. Okay, you will not be provided this list. So you go 1S, 2S, 3S, 4S, 5S, 6S, and then P starts on level 2. 2P, 3P, 4P, 5P, 6P. D starts on level 3. 3D, 4D, 5D, 6D if you want. Oh, there's no such thing. And then F starts with 4 and 5F only. You can go to 6F. Oh, there's supposed to be 7S too. You can do this for the sake of making it look pretty nice. 7. I don't know why I wrote 4. 7F. There you go. All right. So how do you follow this rule? All right. You draw. It's called diagonal rule. So you're not going to go straight down. You're not going to go. You're not going to. So what not to do? Not. You don't go 1S, 2S, 2P, 3S. You don't read it like a book. You don't read it like you're reading top to bottom like a sentence, top to bottom, left to right. Okay. So what you're doing is you're going to follow a diagonal. You start back this. This is the start line. Okay. Lowest energy is 1S. You go like that. 1S. And then once you're done with all that diagonal, you go back to the line, 2S. And then you go to 2P, 3S. Okay. Back to the line, 3P, 4S, 3D, 4P, 5S. Okay. Back to the line, 6D, 5P, 6S, 4F, 5D, 6P, 7S. If you know how to follow this, this is going to make your life so much better because I don't know when you'll use this again, but Okay, it'll make your life for the next couple of weeks, days, a lot easier. And the rules right here as well. Okay, and I'm gonna go through that one more time, just so that those of you don't understand it or don't get it. What's the order? So you would write the order like this. Follow that line. 1s, 2s, 2p. See, 1s, 2s, 2p. What's after 2p? 3s. What's after 3s? 3p. What's after 3p? 4s. After 4s is 3d. So we're just getting this in order. This is following the off-bow principle. There you go. This is the off-bow principle. What's after 3d? 3d, 4p, 5s. 4d, 5p, 6s. Always go back to the line. 4f, 5d, 6p, 7s. So you just go through that. Okay? And so let's apply this. Electron configuration for hydrogen. For example, this little list right here. You need the diagonal rule on the left side. You need a periodic table so you know how many electrons there are. So it's nice. Let's go and fill out the number of electrons for these elements first. Hydrogen, for example, here. Hydrogen, its atomic number is 1, so it's got 1 electron. These are all neutral, right? Neutral because we haven't lost or gained any electrons. So these are neutral ground state, the lowest energy level. So it's going to have the same number of protons and neutrons. Helium, atomic number 2, there's 2. Lithium, atomic number 3, so there's 3. Beryllium, atomic number 4, so there's 4. Then we jump to magnesium. Atomic number is what? Magnesium's right there. Right there. Right there. Next to Na. Mg. OMG. 12 electrons. And then iron is 26 electrons right here. And sulfur is right here, atomic number 16. So 16 electrons. Okay. So if you have that, we go in this order, kind of like this. The first thing is 1s. Okay. And we only have 1 electron, so we put that 1 electron there. 1s1. That's the electron configuration for hydrogen. For helium, it'll be 1s, and it can hold 2, so 1s2. So now this s orbital is full. We have to go to the next thing. What's next on the diagonal rule? 1s after 1s is 2s. 2s, I'm sorry. We only have 2. What am I talking about? IDK. Okay, that's helium. 1s2. We're getting ahead of myself. And then down the next element, lithium. We have 3 electrons, so we got to fill until we have 3. 1s2. And then what's after 1s? 2s1. Alright? So I forgot to mention here, this is the number of electrons on top. The number of electrons. Right on top of that little letters tell you how many electrons. So these numbers need to add up to the total number of electrons. And when you do, you stop. Okay? You don't go more than that. If you go less, then that's not enough. You have to keep going until you get there. 4, beryllium. So you go 1s2, 2s. S can hold how many? S can only hold to 2. It cannot hold more than 2. Okay? If you have more, you put 2 there, and then you go to the next one. Okay? And it, surely enough, it does add up to 4 up here. Right? 2 plus 2 is 4. Alright, magnesium now. It gets a little more challenging here. Magnesium is 12 electrons. So you go 1s2. That's 2. We need 10 more. What's after 1s? 2s2. That is 4. Then what's after 2s? 2p. And the p sublevel can hold how many electrons? The p sublevel can hold 6. So we can put 6 on there. So now we have We can hold up to 6. It's going to hold 1, 2, 3, 4, 5, or 6, but we need 6 because we need to get to 12. How many is that so far? 6 plus 2 plus 2. That's 10. We need 2 more. So what's after 2p? 2p or not 2p? Well, after 2p is 3s. Okay, follow the diagonal rule here. Again, 1s. Okay, back to the line, 2s. Back to the line, 2p first, and then 3s. Okay, and then 3s, we need 2 more, and perfectly there, that's 12 electrons for magnesium. Okay, pretty neat. And then iron, on the other hand, I can show you this another way here. It's just a little more work. All right, you can go ahead and put 1s, put the order 1s, 2s, 2p, a little spacing between them, 2p, 3s, 3p. What's after 3p? 4s. What's after 4s? Back to the diagonal rule, 4s. Go back to the line, 3d. What's after 3d? 4p. Okay, so kind of do that, and then here, and then we just fill in until we get to 26 electrons. S can hold up to 2, so it's 1s2. 2s, 2. Okay. P can hold 6, so keep track of your numbers. 2, 4, 6 is 10. And S here can 2 more, that's 12. Remember, S can only hold up to 2. P can hold up to 6 more, that's 18. Then S can hold up to 2 more. Again, S always only 2 max, nothing more than 2. Okay, and so how many is that so far? 2, 4, 10, 12, 18, 20, and now we need 6 more, so 3d6. So notice that I don't use the 4p, so if you use a pencil, erase that, and then you'll need that. So it ends there, 4d6. D can hold up to how many? D can hold up to 10, but we only need 6, so we only put 6 in that electron. If you put 3d10, that's another element. That's too much. We only need 26 electrons to put in those orbitals. Okay, so 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. That is the electron configuration for iron. Okay, and sulfur here, the next thing. Sulfur is, again, 1s can hold to 2, 2s can hold to 2, 2p can hold 6, that is 10 so far. I need 6 more. What's after 2p? 3s can hold 2. And then that's 12, so then what's after 3s? 3p. We only need 4 more to make 16. Again, all these little bitty numbers on top need to add up to your total number of electrons. Okay? So why is this important? Question is, when we work with the atoms, electrons are the ones that are doing all the reaction, all the bonding, and all the breaking of bonds, and all the sharing, and all the donating electrons. So it's important to know where these electrons are. It's important to know what energy level they're on. And when we come to valence electron, those are the guys that are really doing all the work when it comes to bonding. And so we'll go over what valence electrons are in the future using these electron configurations. Okay. So now is your turn to practice. Now is your turn to practice here. Okay. Let's do one more together. Let's pick something that is a little longer here. Tin, Sn. Sn is 50. You look at the periodic table, it's this element right here. Okay? Tin is 50. Sn is 50 electrons. So yes, we're going to have to go all the way to 50 here. So diagonal rule on one side. Get this out. You can eventually cut and glue all these into your notebook, so feel free to tear this out. Okay, so here it is. I'll put it on the side like this so we can see. Beautiful. Beautiful. So you go 1s2, that's 2. 2s2, 2p6. 3s is next. 2. 3p6. After 3p is 4s2. After 4s is, you go back to line, 3d10. After 3d10 is 4p6. 5s2. Okay, now we need to go back and see how much we got so far. 2, 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, 20, 30, 36, 38. We need to get to 50. We need 12 more. 5s. What's after 5s? 4d can get 10 more. And then after that, we only need 2 more. And then we give 5p2. And that is electron configuration for 10. Okay? Wait till you get to uranium here. Uranium has 92. Why would I do that to you, right? To be honest, I did make this paper, so why would I do that to you? I don't know. Because, I don't know. I really don't know. Okay, another one. Let's do a couple more. Aluminum. Aluminum's 13 electrons. And I like to also do, well, we did helium earlier. It's 2 electron. It's just 1 s2. It's real simple. Okay, aluminum, 13. Okay. 1 s2, 2 s2, 2p6, 3 s2, 3 p6. Nope, that's too much. 2, 3 p1. That'll give us 13. It can hold up to 6, yes, but we only need 13. And there you go. Notice what I want you to look at now is the last thing that's on there. Okay, 3p6, 5p2, 3s, 1s2. The last thing that are on these things. Okay, and you're going to go back to a periodic table. And remember this little periodic table in the front right here? Okay. Everything in the first 2 column here, this is your S block. Okay. This is the S block. This is the P block over here. All elements in this section will end in something P. Okay. Let me zoom in real quick here to show you that. And then every little thing that ends in the transition metals here will end in D. And pretty clear now, the very bottom part. Everything down here will end in F. This is your F block. This is your S block. This is your D block. This is your P block. Okay? S, P, D, F. So the periodic table is arranged really nicely. So if you know where the element is on the periodic table, you can write on the periodic table in your notebook, or you can ask your teacher for a new periodic table. For my students, actually I'll make copies for both mine and Ms. Carrasco's students to have a nice new periodic table so you can draw all over it. It helps you learn this part right here so you can have a separate periodic table. So this one, S block, okay? S. Over here, P block. In the middle, D block. And at the very bottom down here is your F. Remember, how many electrons can the S hold? Can S hold? S can hold 2. That's why there's only 2 columns. Okay? P can hold how many electrons? P can hold 6. That's why there are 6 columns. D can hold how many electrons? 10. That's why there's 10. Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 block. You see? And then F down here can hold how many blocks? How many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Makes perfect sense now, doesn't it? 14. There you go, 14. Oops. So, what does that mean? So let's look at the P. Remember the P and the S. P and S are P and S, the row number. Okay, putting the word wrong. The row number is the number in the front. For example, if the ending is, let's go back to aluminum here. Look, aluminum, the configuration is 1s2. The aluminum, the configuration is 1s2, 2s2, 2p6, 3s2, 3p1. Okay? Look at aluminum. What row is it on? It's on row 3. Okay? So the S and P will have the same rows. Row 3, what block is it in? It's in the P block. It's the first element of the P block. So it's row 3, P block, element 1, 3p1. Guess what? Silicon would end in 3p2. Phosphorus would end in 3p3. You follow? Okay. And what would nitrogen end in? It's on row 2, so it's 2p. So this is 2p, 3p, p, 5p, 6p. Well, this is still s. This is 1s here for helium because it's only got 2 electrons. Okay. So this is 2p3. So you did your configurations correctly. It would end in 2p3. Look at tin. Tin is here. Sn. What should it end as? It should in row 5, so it's 5p1, p2 is the second element in the p block, so 5p2. So let's go back to our configuration and check. The last thing on there is 5p2. Oh my goodness. Can you believe that? Yeah, it is that awesome. Okay. So what if it's strontium? Strontium here. Okay. So then strontium is the same thing. 1s, 2s, 3s, 4s, 5s, 6s, 7s. So strontium would end in the S block. What row? Row 5. So it's 5s2. 5s2. So strontium is 5s2. What would lithium be? 2s in the first column. Row 2. So it's 2s1. So if you flip back to the first page, you'll see that. Look at lithium. 2s1. Check. How awesome is that? Magnesium. Look for magnesium. Element number 12 right there. What should it end as? Row 3, 3s2. So look at that right here. Oh my goodness. It makes perfect sense, doesn't it? It does. And the last one, the very last one, iron. Iron is right there. Number 26. Number 26 right here. Okay? Well, it's in the D block. Okay? The D block is always one lower than the S and the P. So this is 3D, 4D, 5D, 6D. It's always one lower. Okay? Why? I don't know. Well, I should know, but I don't remember. So here, D is always one lower. Just remember that. So it's D1, D2, D3, D4, D5, D6. 3D6. And we look at our electron configuration here. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6 is the last thing. Oh my goodness, again. Doesn't it amaze you one after another? I think that's what I do. That's what I do. I amaze you with this stuff. Pretty cool. Pretty cool. So you go back and you finish all these here. Go ahead and check your, work it out. Complete this page. And then at the very bottom, you simply identify what the element is. This is so easy here. Ladies and gentlemen, don't stress yourself over this. A lot of letters, a lot of weird looking stuff. It doesn't make sense to you any sense at the beginning, but now I'm sure it makes a lot more sense. So, simple here. Well, you can look 4p4. The last thing is 4p4. So, go to your periodic table, 4p4. Let's see. 4p4. 4, row 4. Go to P block. 1, 2, 3, 4. Selenium. It's better be selenium. Se. And if you want to check, you can add up all the electrons here. 2 plus 2 is 4, plus 6 is 10, plus 2 more is 12. Zoom this in so you know what I'm talking about. 12. So I'm going to start over here. 2, 4, 10, 12, 18, 20, 30, 34. Element number 34, and doesn't fail us. Element 34 is selenium. Se. So you put those elements there. Pretty simple. And then 4p5 is one more over, right? Because 4p4 is selenium, 4p5 is the one next to it. 4p5, bromine. So that is bromine. Oh my goodness. Can you believe it? This makes no sense to you at the beginning of class, and now it makes complete sense. Okay? I will make a video for the next paper over. Yeah, for the next paper over, I will make another video. This one's already 30 minutes long. You need to take a break from the video so you can do this paper. Anytime you need to rewatch this, rewatch it. Okay? Don't forget to like and subscribe. Oh, just kidding. You don't need to do that.